Alright folks, in this video I'd like to take the opportunity to help you out with how to add and subtract like radicals. Okay? In the previous video we discussed simplifying radicals. I actually made a second video for that to maybe help you out a little bit further on some of those homework problems. So please check that out if you're having a hard time on any of those. But we will of course be simplifying more radicals today, however with the addition of knowing how to add and subtract them. Adding and subtracting is really not that complicated when it comes to radicals. If you already know how to basically combine like terms, that's essentially what we're doing, is we're going to be combining like radicals in a sense. So, for example, we know things like, go back to things we already know. If I had 7x and I saw minus 3x, I realized, I can combine these because they're both x terms. I have 7x's minus 3x's means I have 4x, right? Same principle is going to happen today with radicals. We're going to see which terms have like radicals, and we'll be able to combine them just by simply adding or subtracting their coefficients. Okay? But if they're not like radicals, we'll either try to make them like radicals by simplifying, or we will just leave them be, because we can't combine things that aren't like terms. In this case, like radicals, for instance, if this was 7x minus 3y, I would not be able to combine them because that's the x term, that's the y term, and I just leave it be. It's going to be something similar with like and unlike radicals today. Alright? So you can see an example, of course, like radicals. These here are like radicals. 2 square root of 5 and 4 square root of 5, simply because they both have the same exact radical, right? The square root of 5. Alright, these are like radicals because, again, you can see the square root of 6 and the square root of 6, they're the same radicals. So it's kind of self-explanatory. They're like radicals if the radicals are alike. So square root of 4t, square root of 4t. I understand that there's no coefficient here. Well, there kind of is, like a coefficient of 1. But again, it has the same exact square root, the same exact radical, so they're like radicals. These down here, you can see all of these are not like radicals because this term is the square root of 15, but that term does not have a square root of 15. This one here has a square root of x, but this one's square root of 6x. I understand they look similar, however, they're different radicals. This again is just the square root of x, whereas this one's the square root of 6x. So they don't have the same radical or the same terms or numbers and things inside the radical. As we talked about yesterday, that's called the radicand. Alright, and of course, again, maybe these look similar to you. However, this is the square root of 2, and that is the square root of 3. Those are not like radicals. And they have to be exactly the same if they're going to be like radicals. So they're pretty easy to identify. The hard part of today is, if they're not the same, see if you can simplify them and make them the same. Or if they end up coming out to be the same, you don't necessarily make them the same, but you just kind of see if they are or not. And then just add them together, because it's just like combining like terms. If you have 2 square root of 5 plus 4 square root of 5, these are like radicals, so you can put them together and get the 6 square root of 5. Right? It's the same thing if it was 2x plus 4x would be 6x. It's absolutely no different. But you have to realize that you can only combine these if they're like radical terms. Alright, so let's kind of jump into a few here. 9 square root of 3 minus 4 square root of 3. The first thing I want to do is just make sure they're like radicals. Make sure there's nothing I can simplify either. I know the 9 square root of 3, I cannot simplify this any further. The square root of 3 is as simplified as it gets. Same thing with the 4 square root of 3, that's as simplified as that gets. But notice of course, they are like radicals. They both have square root of 3. So this 9 minus 4, going to combine those coefficients, this will really equal 5 square root of 3. By looking at b now, 6 square root of x, I realize that I cannot simplify this, right? The square root of x is the square root of x. Nothing really I can do about it. Same thing with the square root of y. But realize, hey, I actually can't combine those because those do not have like radicals, right? We have the square root of x here, and this is the square root of y. They're not the same. They're not like radicals. So I can't combine these. They're essentially not like terms. So my answer to this is 6 square root of x plus 8 square root of y. I can't really change it. So that is as simplified as it's going to be. let's try a few others. I have square root of m. Now keep in mind that this is 1 square root of m. It's kind of redundant to write the 1s while you never really see it written, but just remember that there is technically that 1 there. It's kind of like, this is sort of like saying x minus 7x. Technically this is 1x, right? Same things happening here with my square root of m. Again, that is a simplified radical. This is another simplified radical. So let's combine them as long as they're like. Of course, since they're both the square root of m, I can combine this. I'll have, this becomes to be, I believe, negative 6 square root of m. Because 1 minus 7 is negative 6. And d here, this last one, that's a simplified radical, that's a simplified radical, and that's a simplified radical. And again, I know it's simplified because I can't take the square root of x or y, or x or y. So let's combine what we can. Again, I can only combine like radicals. So the only like radicals I have here are the first term and the last term, 2 square root of xy and 9 square root of xy, because they both have the same exact radical. Now, the second term, square root of y, is not the same, so I cannot combine it with those other two. So, I can, however, combine, of course, the first and the last term, so let's go ahead and do that. The 2 square root of xy combined with 9 square root of xy, because these are both positive, make 11 square root of xy. Now, this term, I could not do anything. I cannot combine it to that 11xy, so I'm just going to bring it down and just have that plus 2 square root of y. And that's going to be my final answer there. This essentially can be same as, or related to, the same sense as having something like 2a plus 2b plus 9a. Of course, since these are both a terms, you combine them and get 11a. And since this is just a b term and it does not combine with an a term, you would bring it down and leave this to b. So it's very much equivalent to that. It's the same exact thing as combining like terms. But the catch is, in some of these, and you'll see in the example we'll get to in a minute, is you're going to have to simplify the terms or make sure that they're simplified before you try to start really combining them. Here I gave you some simple ones that were already simplified, just so you get the idea of how combining them works. Alright, but now, of course, we're going to get to problems that are more of something you're really going to see on tests, on quizzes, on things like that. Alright, so the square root of 45 minus the square root of 20. First thing, of course, you realize is these are not like radicals. Of course, you cannot combine them the way they are written currently. But that doesn't mean the problem is done. That doesn't mean the problem is simplified. The square root of 45 is not a simplified radical. Neither is the square root of 20. So let's simplify these first, and then we'll see if we can combine them later. We'll see if they end up being like radicals or not. So this is where, all the work we did yesterday comes into play. So the square root of 45, remember, because of the number, these are the perfect squares. I'm just going to list them out here because I'm going to use them sort of as a reference. I'll kind of stop there. I think that's enough. Square root of 45, to simplify it, you want to find out if there's one of these perfect squares that will divide into 45. And if there is, you want to make sure it's the biggest one. And if you couldn't already see it, 9 divides into 45, right? So we're going to use that. 9 times what makes 45? 9 times 5. 9 times 5 is 45. So I'll have those two numbers. Again, I can break them up, do them separately. Square root of 9, square root of 5. I do know the square root of 9 because 9 is a perfect square. The square root of 9 is just a regular old-fashioned 3. The square root of 5 is my leftover remainder. I cannot really simplify that 5 anymore. So I have square root of 45 simplifies into 3 square root of 5. So now the square root of 20. Of course, that is not a simplified radical either, so let's do the same thing here. Keep in mind, I guess we are technically still have this minus sign. Right there. Alright, square root of 20. So is 20 divisible by any perfect square? Let's actually make this a different color. Because you know what? I'm feeling fancy. Let's do it in red. Alright, square root of 20. 20 is divisible by 4. I believe that's the biggest perfect square that you can divide it by. 4 times what? 4 times 5 makes 20. Alright, same thing. We'll separate these two out. Square root of 4 and then square root of 5. We can do them separately. Of course, 4 being a perfect square. Square root of 4 we know is 2. A regular old-fashioned 2. And the square root of 5, I cannot simplify. It's going to stay in the square root as a square root of 5. So now I've got 3 square root of 5 minus 2 square root of 5. And now you realize, hey, you know what? That term is a like radical with this term. They both have the same exact radical, the square root of 5. So that means I can combine them. 3 square root of 5 minus 2 square root of 5 equals just 1 square root of 5. So I can write 1 square root of 5, but again, typically you can just write it as a plain old square root of 5. And that's my answer. Alright, so this problem, it's very important that you understand this problem because, of course, from the very beginning, it did not look like I could do anything because they were not like radicals. However, each radical was able to be simplified, and near the end of the problem, you see that each term did become actually like radicals with each other, and we could combine them at the end. So simplifying is key. Make sure you look to do that first. And then sometimes, because at the end of the problem, sometimes you can simplify it even more. So, just a heads up, and I'll probably go ahead and show you this. But I'm saying this is equivalent to this. So if you took your calculator and typed in the square root of 45 minus the square root of 20, you'll get the same exact answer as you get with the square root of 5. So that's a little bit of advice or reminder for you. The whole point of this is to write this in the most simplified way possible. It's still equivalent, you know. If it wasn't equivalent, of course, this wouldn't work. But square root of 45 minus square root of 20 should equal this at the end of the day because they should be the same, right? This is just a simplified version of what we started with. So keep that in mind. I would pull the calculator out to show you that, but just take my word. I don't think I can get the calculator out with anything right now. Alright, let's just do maybe one more like this. Now these three terms, of course, are not like radicals currently. I have the square root of 75y, the square root of 27y, and the square root of 48y. Yes, they all do have y's in them. However, remember to be like radicals, the radical has to be the same. So these are all different radicals. They all have different things inside their square root. I understand that they do have a common y, and that's going to matter a little later. But to be like radicals, they have to be exactly the same radical. They all have to be 27y, or all of them have to be 75y. Okay? But ignore that. Alright, so of course I cannot combine these as they stand, but I could simplify them one at a time. So let's start looking at the 75y. Let's use blue for this one. And let's start simplifying this. Now, one thing I like to go ahead and do, and again, once you get really good at this, you could probably make this a little bit easier on yourself and skip all the steps that I write out. Or do some of these steps in your head. But I'm going to be very thorough, or at least while you're starting to learn it. So apologize for that. But keep in mind that this could be a rather simple process once you really, really get the hang of it. Alright, so first thing I'm going to do is separate the 75 and the y, and then do these separately. So the square root of 75, of course 75 is not a perfect square. But I'm going to go ahead and write my perfect squares down here again. I think that's really all I'm going to need right now. But it is divisible by this perfect square, 25, right? 25 and what makes 75? 25 and 3. So 25 and 3, I'll separate these out, break them up. Of course, the square root of 25, because it's a perfect square, is just a regular 5. The square root of 3, I cannot simplify that anymore. It gets left and brought down. Of course, the square root of y cannot change, so it really stays the square root of y the whole way. And of course, at the end of the problem, that's going to be with that 3. So really, this first term is going to be 5 square root of 3y. I can combine these two, put them back in the same radical at the end of the problem. So that's what I was saying earlier about, kind of being able to do some of this in your head. You might realize that this y is always going to be inside the radical once you get good at these problems or used to these problems. And you might not need to separate it out because you realize, it's going to be inside the radical at the end of the problem anyway. So, but it's okay if you do it as very thoroughly like I just did. I don't want to leave any gaps, so I do try to be very thorough and complete here. So let's move on. Second one. All right. Now notice the 2's on the outside. That 2's going to be there. Let's keep that in mind. But let's focus on the square root of 27y. All right. So I'm going to go ahead and separate the square root of 27 from the y, just like I did previously in the 75y. So, of course, I can't really change the negative 2. The square root of 27. 27 is not a perfect square, but it is divisible by a 9. So let's break this into 9. And 9 times what? 9 times 3. Right? Of course, square root of y I can't change, so I'm going to bring that down. Square root of 9. Separate that from square root of 3. Of course, bring the square root of y down. Now, the square root of 9 is 3. This is multiplying, by the way. Square root of 3 I cannot change. The square root of y I cannot change. So at the end I have negative 2 times 3, which is going to make this negative 6. And the square root of 3 and the square root of y combine to make the square root of 3y. Alright, so really all I did in this problem was separate a 9 out and square root that and combine that 3, because the square root of 9 is 3, with that 2 to make 6. The 3 and this y kind of get left under the radical the whole time. Alright, let's move on to the last one, the 48y here. So square root of 48y. We'll go ahead and separate these. So square root of 48, square root of y. Of course, 48 is not a perfect square, but it is divisible by 16, I think, right? Or am I wrong? Hold on, I might be wrong. No, it is 16. 16 times 3. Of course, I'm going to leave the square root of y alone. I can't really do anything about that. So we'll separate these out. The square root of 16, separate that from the 3. Of course, again, the y is still there, being its own little separate thing. The square root of 16, I know the square root of 16 is 4. The square root of 3, I can't change. The square root of y, I can't change. So at the end of this, I have 4, and I can put the 3 and the y together in the same radical. So I've simplified all 3 terms. These 3 terms are the same as these 3 terms. But now, these are the simplified versions of each of them. But, you know what? Look, at this point now, realize, hey, that's a square root of 3y. That's a square root of 3y. That's a square root of 3y. All 3 of these terms are like terms. So I can combine them all together into one term. I have 5 minus 6 plus 4. 5 minus 6 is negative 1, and negative 1 plus 4 is 3. So this would be 3 square root of 3y. And that would be my final answer, I believe, or my final simplified expression. So again, all this stuff up here, it's all equivalent to just 3 square root of 3y. It does take a little bit of work to get there because there's a lot of problems in one, essentially, because there are 3 terms. We do have to simplify all 3 terms and then combine them at the end. So that's why simplifying the work we did yesterday was super important. Obviously, you would not be able to do this problem if you could not simplify. So combining like terms is super easy. Combining like radicals is super easy. It's the simplifying that we talked about yesterday that if you don't get that part right, obviously, then you don't have the opportunity to combine like terms, and you mess up something there. You can't get to that point in the problem. So please make sure you can simplify. Again, if you had a hard time simplifying anything here, come see me or tutoring. I'd be happy to help. With that said, folks, I'll leave you at that. I'll see you in the next one when we multiply and divide.